Space travel will morph the shape of your brain. When traveling into space, your brain will literally change shape. In a recent study published in Nature Microgravity, researchers found that astronauts' brains change shape in outer space to adapt to microgravity. Using MRI scans from before and after space flights, researchers found that gray matter, the darker tissue that processes information in your brain, decreases in some areas and increases in others. During spaceflight, the brain compresses and expands, and the extent of these changes depend on how long astronauts are in space. This is because changes in gravity affect the cerebrospinal fluid in the brain, says principal investigator Rachel Sadler, professor of kinesiology and psychology at the University of Michigan. When you're on Earth, you can imagine that gravity is pulling fluid down in your body, but in space you don't have gravity to do that, so the fluid is shifted up towards the head. I don't want to give people the impressions is that you're losing brain cells, Sadler continues, but it could potentially be shifting the location of the brain in the skull or compressing it. Astronauts who spent a longer time in space experienced more changes in the brain. Sadler believes gray matter increases in the parts of the brain that control leg movement, possibly because the brain adapts to moving the body in microgravity. This effect, or the ability of the brain to reorganize itself to form new neural connections and adapt, is called the neuroplasticity effect. That way, astronauts learn new motor skills and get better at moving through space. You're floating, and in a sense it's like swimming, Sadler says. You're using your brain differently. Your muscles are contracting differently. We see that the regions increasing are the brain learning how to move the body in space. The more you learn, the better you learn with adapting to the microgravity environment. Previously, Sadler found that extended space missions affect astronauts' inertia, which decreases their balance abilities. And since the brain has changed and adapted to space, astronauts may initially have a difficult time walking and standing up straight when they return to Earth. But even as the brain learns to adapt to Earth's gravity again, it may take a different pathway to make up for structural brain changes from spaceflight. Sadler plans to continue studying how shape changes in the brain affect behavior and thought. Right now, she's in the middle of a study testing balance, motor function, short-term memory, mental rotations, and other brain abilities of astronauts up to 6 months after spaceflight. This will help her team better understand if these brain changes reflect brain plasticity. These findings might help researchers develop better treatments of other health conditions that affect brain function, such as normal pressure hydrocephalus, a condition where cerebrospinal fluid causes pressure in the brain and can affect leg movement, the bladder, and mental processes. More likely, in the future when humans embark on longer flights, potentially to Mars, this research can help scientists better understand how people's brain functions will adapt in space. I think it will be important to understand, if people are in space longer, what it might that mean for brain function when people get to Mars, or what that might mean for recovery functions when they get back, Sadler says.